Okay, today we're going to start notes on system of linear equations. And before we can talk about systems, we need to know if you remember how to know if a point is a solution to a linear function, which means is the solution means if this point is on the line. Okay, so I'm going to go ahead and zoom in a little bit. Okay, so here's our example. Is 2, 5 a solution to y equals 2x plus 1? Well, this is our x-coordinate, this is our y-coordinate, and we're going to plug those into the equation. So y is equal to 5, 2 times 2, because x is 2, plus 1. So I'm going to see 5, and then I'm going to simplify. So 2 times 2 is 4, plus 1, and then simplify 4 plus 1, I get 5. So 5 equals 5. That is a true statement, which means that yes, 2, 5 is a solution to y equals 2x plus 1. Our second example I have is 1, negative 9, a solution to 2x plus 3y equals 25. So again, this is my x-coordinate, this is my y-coordinate, and I'm going to plug those in. So I've got 2 times 1 plus 3 times negative 9 equals 25. If you have your calculator handy, you can definitely use it. I'm going to use the calculator here. So I'm going to do 2 times 1 plus 3 times negative 9, since those are all constant numbers, and I get negative 25. So is negative 25 equal to 25? No, it's not. So that means it is not a solution. Okay, a system of linear equations is made up of two or more equations. Is made up of two or more equations. A solution to a linear system is the point of intersection. So these two lines are going to cross each other. They're going to intersect. And when they intersect, that point is the solution to the system. What that means is that point works for both one equation and the other equation. So it works for both equations. Solving a system by graphing. Graphing is one of the methods that we use to solve a system. This works particularly well when they're already in slope-intercept form, like our two equations are here. We have y equals negative x plus 4, and we have y equals 2x minus 8. So I'm going to zoom in again. And I'm going to graph these two lines. We're already familiar with graphing. Y equals negative x plus 4. 4 is my y-intercept, so I'm going to start my first graph up at 4. And my slope is negative 1, which means I go down 1 to the right 1. I'm going to mark a few points. I'm not going to do all of them. And I'm going to draw my line through my points. And now I'm going to switch colors. I'm going to go to red so I can differentiate between the two lines. Y is equal to 2x minus 8, so I'm going to start down at negative 8. And my slope is 2 over 1, so I'm going to go up 2 to the right 1. And you can see I've already crossed my blue line. I'm going to try to draw a straight line through those points. Okay, so what we're looking for where those two lines cross. That is called the point of intersection. That point is our solution. So I'm going to find out what point that is. So I'm going to come over here, 1, 2, 3, 4, and I'm not going up or down, so that's 0. 4, 0. That is my solution. How do I check it? Well, just like I did in the first couple examples, I'm going to plug them in and see if it works. So 0 is y. That should be negative, and then my x is 4 plus 4. So that gives me negative 4 plus 4, which gives me 0 equal to 0. So it checks out in the first equation. The second equation, I'm going to plug in 0 for y equals 2 times 4 minus 8. And I get 0 is equal to 8 minus 8. I'm going to multiply first, order of operations, and 0 equals 0. So that checks out. What about this table of values here? Let me zoom out. Table that shows the solution. Well, I can come back to my calculator. Let me find a space that's kind of out of the way. And we can go to y equals, and I can put those equations in. Okay, so your graph already has y equals. So all of the graphs that we put in here do have to be in slope-intercept form. So I'm going to type in negative x plus 4. And in the second line, I'm going to type in 2x minus 8. And I'm going to look at the table function. The table function is written in yellow here, second table. And we said our solution was 4, 0. So let me come here and look at 4. And what do you notice about y1 and y2? They both contain 0. All of the other numbers are different, but this one contains both zeros in y1 and y2. So that's what they want us to see. What is it going to look like in the table? I should see the x is 4, the y is 0 in both equations. Okay, number 2. Let me zoom in. I've got y equals 5/3 x plus 1 and 4x plus 3y equals 30. This one I can go ahead and graph. It's in slope-intercept form. This equation I'm going to have to solve for y first. I'm going to go ahead and graph the first equation. So I'm going to start up at 1. I'm going to go up 5, 1, 2, 3, 4, 5, and to the right 3. And I'm going to do one more point. 2, 3, 4, 5. Oops, I lost count. 1, 2, 3, 4, 5, negative 5, and go over 1, 2, 3. Okay, so there's 3 of my points. I'm going to go ahead and draw a line through those points. Now, my second equation, I'm going to have to solve for y first, so that means we have to get rid of the x term. We have lots of practice. So that means I've got 3y left over equals the negative 4x plus 30. And then I've got to divide by the number in front of y, so dividing by 3. And this equation comes out to y equals negative 4/3 x plus 10. Okay, so that means, let me change colors here. I'm going to start up at 10, and I'm going to go down 4. 1, 2, 3, 4, and to the right 3. Oh, I can see it already crosses my blue line. 1, 2, 3, 4, to the right 3. So I'm going to go ahead and draw my line through my points. And again, the point of intersection is where my two lines touch, and they touch right there. So I need to go ahead and find out what point that is. So I'm moving over 1, 2, 3 units. So that's moving over 3. That's my x coordinate. I'm going up 1, 2, 3, 4, 5, 6 units. So I've got 3, 6 for my solution. So I'm going to check that. So I plug in 6 for y. I get 5/3 times 3 plus 1. 6 equals, and I'm going to use my calculator. And I'm going to do 5/3. I'm going to put that in parentheses. That's a fraction. Times 3. And that gives me 5. So I get 6 equals 5 plus 1. And 5 plus 1 gives me 6. So I do get 6 equal to 6, so that checks out. My second equation, 4 times 3, x is 3, plus 3 times 6 equals 30. I'm going to pull up my calculator again. I'm going to do 4 times 3 plus 3 times 6, and that comes out to 30. So I get 30 equal to 30, and that checks out. Now, what should it look like on the table? Well, if the x is 3, then my two y values should be 6. They should contain the same y value. Okay, example number 3. Now both equations are in standard form, so I am going to have to change both of them before I can graph them. So I'm going to take the negative 18x plus 6y equals 24, and I'm going to add 18x to both sides because we've got to get rid of x, and that leaves me 6y equals the 18x plus the 24. Divide by the number in front of y, so I'm going to divide by 6. Y equals 3x plus 4. So that's my first equation. I'm going to go ahead and solve for the second one. You may choose to graph it at this point. We have 3x minus y equals 2. I'm going to go ahead and get rid of x by subtracting 3x. I get negative y is equal to negative 3x plus 2. And then I have that negative y. I need a positive y, so I'm going to divide through by negative 1. And I get y equals positive 3x minus 2. Okay, so I'm ready to graph. I'm going to start my first one up at 4. So I'm going to count up at 4. And I'm going to go up 3 and to the right 1. And get a few points on here. Uh-oh, I moved my graph. Okay. 1, 2, 3, to the right 1. 1, 2, 3, to the right 1. That should be enough points to give you an idea of where the line is going. Okay, my second graph starts at negative 2, and it goes up 3 to the right 1. They have the same slope. What do we call lines with the same slope? They're called parallel. Well, parallel lines don't intersect. So what does that mean for our solution? Our solution is where those two lines touch, and those two lines aren't touching. So what that means for us is there's no solution. They don't touch. They don't intersect. Okay? So parallel lines do not intersect. There will be no solution. Now what that looks like on the table, that means they're going to have different y values. So if I pick x as 0, which is their y-intercepts, I'm going to have a 6 on the first equation and a negative 2 on the second equation. So they don't intersect, so they're not going to be the same y values. Okay, example 4. My first equation is not in slope-intercept form, so I'm going to go ahead and change that. I'm going to subtract x from both sides. I get negative 2y is equal to negative x minus 4, and then I'm going to divide by negative 2. Simplified, I get y is equal to negative and negative is positive 1/2 x, negative and negative is positive 2. Okay, so I'm going to go ahead and graph this line. I'm going to start up at 2. I'm going to go up 1 to the right 2. And I'm going to draw my line through my points. And then I'm going to draw my second line. Y equals 1/2 x plus 2. Well, that looks familiar. Oh, it's the same as the blue line. So what we have here is my blue line and red line are right on top of each other. They're called coinciding lines. They coincide with one another. One's on top of the other, or they're the exact same line. So what does that mean for us in our solution? Well, all of those points I plotted are solutions. They match up with both the equations. We're trying to figure out what points those equations have in common. And when one's right on top of the other, or when they're coinciding, that means we are going to have an infinite number of solutions. Okay, that sideways 8 means infinite. All of the points, every single one of them, on forever and ever and ever. So these are called coinciding lines. Means they're together and they have the same points. Okay, all of the points are a solution. So that means there's an infinite number of solutions. What does that look like on a table? Well, it looks the same. It doesn't matter what x I pick, those y values are always going to be the same because they're the same points. So if I plug in 0, then you've got 2, and this one's going to be 2 as well. Whatever point this is going to be the same point. Okay, here's some examples to try on your own. And I'm going to show you a little trick on the calculator. So I'm going to pull up my calculator. And I'm going to go back to y equals. I'm going to clear these out. And I'm going to type in these equations. So I'm always going to put my fractions in parentheses just because it's good practice. 4/3 x plus 3. And then I get negative 2. Oops, I hit 5 on accident. Negative 2 divided by 3 x minus 3. Okay, then I'm going to hit my graph button because I want to graph these. And you can see they came up pretty quickly. As long as you see the point of intersection in your window, you're good. Now, this calculator will actually tell you what the point of intersection is. If you will go to second and trace, choice number 5 is intersect. Well, that's what I want. I want where the lines intersect. So they're asking me for the first line. The first line is right here. It's telling me y1. Do I want to choose y1? Yes, I do. So I'm going to hit enter. Then it jumps to the second line. Is this the second line you want to do? Yep, that's my second one. So I'm going to hit enter. And then it says, do you want the calculator to guess? Yes, you do. So then it tells you the point of intersection. So my solution here is negative 3, and I missed the y value, negative 1. Okay, so the calculator will calculate the point of intersection for you. Okay, number 2. So that means I'm going to come back to my calculator and I'm going to clear these out. And I'm going to go and put these next two in. So I've got negative 0.5x, and I left off my negative. Negative 0.5x. And I've got parentheses negative 3 over 2 x plus 4. So I'm going to hit graph. Okay, and I see my two lines, they do intersect right about here. So I'm going to go second, trace. I'm going to go down to 5 and hit enter for the first line, enter for the second line, and enter again for it to guess. And it tells me my point of intersection is at 4, negative 2. So my solution is 4, negative 2. Now when I get to number 3, I can go ahead and put in the y equals x plus 4, but I have to solve for y on x plus y equals 2. So to do that, we subtract x from both sides, and I get y equals negative x plus 2. So this is the equation I'm going to use in the calculator. So again, I'm going to go back to y equals. I'm going to clear out my previous entry, and I'm going to type in x plus 4. I'm going to go down, and I'm going to type in my new entry, negative x plus 2, and I'm going to press graph, and they intersect, and I can see their point of intersection. I'm going to calculate it. I'm going to do second trace, go down to choice 5, and I'm going to hit enter 3 times. 1, 2, 3. So my point of intersection is at negative 1, 3. Okay, the point of intersection is at negative 1, 3. Number 4, got to do a little work first. I've got to get both of these equations into slope-intercept form. So for the first one, I'm going to take 6x plus 2y equal to 8, and I need to solve for y. So I'm going to subtract 6x from both sides. Get 2y equals negative 6x plus 8. Divide by 2. And my y-intercept form is going to be negative 3x plus 4. My next equation, I have negative 3x plus 4y equals 16. I'm going to add 3x to both sides. I get 4y is equal to 3x plus 16, and I'm going to divide by 4. And y equals 3/4 x plus 4. So I'm going to write that underneath this other one because when my calculator comes up, I think it's going to cover it up. Okay. Now I'm going to take my calculator. I'm going to clear out my previous selection, and I'm going to type in these two new equations that are from standard form that are now into slope-intercept form. So we've got negative 3x plus 4, and we have 3/4, oops, press 7 instead of 4, 3/4 x plus 4, and I'm going to hit graph, and they intersect, and you'll notice that these two y-intercepts were the same, so that tells us that they're going to start at the same place. So that probably kind of already tells us what our point of intersection is. It's going to be at that y-intercept, but we can go ahead and calculate it. Go to second trace, and then we're going to go down to 5, and we're going to hit enter 1, 2, 3 times, and we are correct. It is the y-intercept at 0, 4. Okay, so that's how you use your calculator to graph the equations and find the point of intersection. You do have to get the equations into slope-intercept form first.